LMBench, where you should be able to easily run the various workloads on open source serving engines and through a single configuration file, which is bench spec, which is right here. So I'm going to do a short tutorial. I've prepared a Hugging Face token. I will delete it later. So this is a single configuration file. I've already cloned LMBench, and I've also installed all of these requirements into my virtual environment. So I'm going to start it right now, and I'm going to pass some extra flags. So the ignore data generation is because I'm using ShareGPT and I already installed the data set, and it takes a while. So I didn't want to do that again. And the start from 2 is that if you see 1, 2, 3, 4 here, there's 3 steps of the pipeline: infrastructure, serving engines, and workloads. I'm starting from 2 because for the infrastructure, if we look to this template on how to configure our configuration file, the options are minikube and LMCache. I already did the minikube cluster, so I'm just going to start from the serving engine, so it doesn't take that long. And so let's looking at the ways to configure. As I mentioned, there's 3 steps. Infrastructure minikube is the local version where you clone, but eventually, hopefully, we have LMCache GKE, and the goal of that is to have a GPU runner, hopefully with a sizable number of GPUs, and that's going to be combined with this workflow right here. It's currently not complete, but eventually others can come to this benchmarking platform, do a PR, and once the push is accepted, then it'll trigger benchmarks to be run. And when they push, they should modify this. What did I just do? What did I just do? Okay, I have no clue. What did I just do? Okay, no, I didn't do anything. Cool. So they should just easily be able to modify this file, create a PR, push, and then that's going to cause it to run on the LMCache GPU runner. So that's in the future. Right now it's just minikube. And for serving, looking at serving engines, Dynamo, Production Stack, SGLang are the 3 that we want to test. Right now in the minimal example, only Production Stack works. In the future, these should all be configurable. And lastly is the workload. And so there's a couple workloads we want to run. Right now only ShareGPT is supported, and this is how you configure it. So once again, this is a single configuration file where everything should be controlled from. And just very briefly, I guess how a production stack works, there's this baseline config file, and what it does is it takes these values and then it overrides from the baseline, and then it creates this temporary new production stack config, and that's what Helm actually deploys. So for example, here you see the Hugging Face token is appeared. It was taken from here and injected into here, and this is what Helm is deploying. So to-dos for LMBench, so we can see first of all that the 2 pods are running, and now the benchmark is starting officially. So to-dos for LMBench, obviously, actually these are already implemented in the LMBenchmark repo. They just need to be moved here and automated. This is the top level control everything. As I mentioned, this is a simple pipeline. The main literally just runs 3 steps: set up infrastructure, set up baseline, and run workload. And you can skip one of these steps by setting start from. And so we need to implement these, and then also just actually not implement, just migrate, and then make it automated. So just recall that I only had to do 2 things. I had to modify this, and then I had to just call run bench, and eventually the platform should support users modifying this file, creating a PR with LMCache GKE specified, and then their serving engine and workloads that they want to run. And then once we accept it, it should run on the LMCache GKE. And just finally, just summarizing, all the results will come here. And then to do also is to, I guess, have some of the artifacts put into the README, so the latest results are always immediately visible. And yeah, the main to-do is the LMCache GKE. I'll speed this up once the artifacts are done. Okay, so the results came out, and you see they're here. And so for the 1.34 queries per second, we get the TTFT and the approximation of the ITL, and same here, and they're pretty similar. And that was completely automated. That was I just ran a single command here, and it went from here I didn't demonstrate, but you can go from infrastructure to serving engines to workloads to results in a single command, and eventually the main goal is to have the workflow.